So all of our notes should be out, and we are going to work on, should be questions 7 and 8, and then the 2 before that. So secant is the sister to who? Cosine. So we're going to compare this.
Good afternoon, teachers and subs. It's time to check that 6th period tab or printout to see which students need to head to their testing room at this time. Please dismiss them. Thank you.
So the fun thing about these problems is that we are going to just literally graph our cosine function, but we're not going to connect the dots. So does cosine start at the top or in the middle? The top. So we're going to start there. We'll draw our thick tick marks. And what do our tick marks represent? Every tick mark, not just the thick ones. Pi over 4, yeah. But we're only going to use the thick tick marks to graph the parent function, so then at pi halves will be at 0. Pi will be down at -1. Okay. Again, do not connect your dots. But does everyone have the idea of their graph built? Like everyone has their dots placed? Okay. So now everywhere that there's a dot on the midline, you're going to draw a vertical asymptote. So a dotted line anytime that there's a dot on the midline. And now the only things that we have left are our peaks and our valleys. So the highest point in our range and the lowest point in our range. So if it's at the top of the mountain, we get to draw a smile. If the point exists on the bottom, we draw a frown. And then you don't have to do this, but I'm going to draw our parent function in red so that you can see what we didn't connect, but just so that these points just touch at those dots that they're meeting at, and then they don't touch anywhere else. Good. We're going to come back to our domain, but our range, at the end of the day, our range is going to be, when you combine these two functions, negative infinity to positive infinity. On just our parent function of cosine, what was our range? This red line, what's the range of the red line? -1 to 1. So at the end of the day, to get all of it in there, our range on this function is negative infinity to -1 union 1 to infinity. Because if you look at those peaks and valleys, those are going to go on forever and ever and ever down to positive, or down or up to positive or negative infinity. They just won't touch the lines. Did we have a b value on this graph? No, we did not. So our period gets to still be 2 pi. Now our asymptotes and our domain are going to be a new kind of terminology. So we're going to put that it is x such that x does not equal. Yep, that's why I just said, just give me a moment. So your domain is everywhere except for your asymptotes, which are these green dotted lines, which is why we dotted them. What is this first green dotted line? What's that point in terms of pi? This first big hash mark. Pi halves. So that's why we have this pi halves here. Every single time that we have one of these problems, you're going to include...
We gotta remember that whole domain.
Just let me cook. Every single time, you're going to have everything that's in yellow. The only thing that's going to change is the first dotted line on the right side of the y-axis is going to be right here. So everything else is x such that x doesn't equal pi halves in this case, because that's where this first dotted line is, plus or minus k pi. And k is just any number that's a multiple of it. And your asymptote, I highlighted those because your asymptote is the same thing, but x equals it. This is k, yeah. 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 Yeah, both of these, so the k just represents some multiple of it. So you could have 7 pi, and then you'd add that to pi halves. Add or subtract it to pi halves. Yeah. Maybe after some more, it's gonna like click. We're gonna do the sine inverse. And I'm hoping after we do that one, it might make more sense. Is everyone ready to move on to our cosecant function? Yay. So what graph are we comparing this to? Comparing it to sine. Does sine start in the middle or at the top? Middle. If we draw our thick tick marks, at every other. And then does sine go up first or down first? Which one is it? Yes, up and to the right. Thank you. Okay, so we're going to go up to 1, come back down to 0. Down to -1, back to 0. And then just mirror the other side. Yeah.
What does it mean when you say compare the
So for these problems, you want to just draw the sine or the cosine function first, and then build your inverse function graphs based off of that. Because it's a lot harder to work with the transformations directly on these graphs. So we're going to first work on, like, so for example, this one, we're going to compare it to 2 sine x plus pi halves. Because we know how to graph that decently easily after we've done the last 2 days. And so we're going to actually draw out these dots every time and then just not connect our dots to make a sine wave. Did that help? Okay. The next step that we're going to do is we have an asymptote at all of our midline points. So you're going to draw your asymptote. Mm-mm.
Okay, thanks.
You're welcome. I am Miss Bryant. And then at all of our peaks, we're going to draw smiles. At all of our valleys, we're going to draw frowns. Bless you. So that yellow line, you don't have to draw, but I drew so that we can see where our original sine function was. So let's first do the only thing that we're really comfortable with. Our period. What is our period? 2 pi, because we didn't have anything to change it. Our range is the exact opposite of the range of our sine function. So what do we have? Negative infinity to negative 1, union 1 to infinity. So you skip all of these values in here. But if you were to combine their two ranges, their ranges would equal all real numbers. Okay. Now, we can either look at this dotted line right here that's on the y-axis, or this next one, which is, where is that located? Three pi fours, pi, 3. This one right here is 3 pi over 2. Pi fours, 2 pi halves, 3 pi fours. It's pi. So instead of having anything in front of, you have your x such that x doesn't equal, this time you only have k pi halves because you don't have anything. The first time you have an asymptote is on a multiple pi. So you won't have anything to add or subtract it by. And again, remember your domain and your asymptotes are going to look very similar. So we have x equals plus or minus k pi. Yes, Mensa.
Are you ever going to find
X for what? for the domain and asymptotes? No, because the k is every multiple. Because these asymptotes go on forever and ever and ever, but it's all following a pattern, that's the most work you have to do is that. Is just say that it's a multiple of pi, plus or minus. So this is going to be pi, 2 pi, 3 pi, 4 pi, but all of the asymptotes are going to be on whole numbers of pi, rather than being pi halves plus k pi, if that makes sense. We have 2 transformations to do, and then we're done. So this problem, we're going to compare to what function? Yep. 2 sine x plus pi over 2. So the only thing in our sidelines we don't really have that we can add in for ourselves, amplitude. What's our amplitude? 2. Our domain, we're going to come back to. Our range, we'll come back to. Our period, do we have a b value? No, so our period is just 2 pi. Vertical asymptotes we'll come back to. Our phase shift, we do have an h value. What is it? Pi halves or negative pi halves? So which direction are we going? We're going left. And do we have a vertical shift? None. Which means that our midline is just going to be our x-axis like we're used to. We've already talked about today that sine starts in the middle. I'm going to draw. This is where we would start, right there, if we were looking at the parent function. We don't have any vertical shift, but we do have a horizontal shift, and it's over 2 pi. So this is our new 0, right there. And then because our amplitude is 2, we're going to add and subtract 2 from 0 every time that we move. So at 0, we're going to be up at 2, and we're going to come back down, go down to -2, back to 0, up to 2, back to 0. What is our next step once we have our dots placed? Vertical asymptotes. And it is everywhere we have dots on the midline. And then we get to draw our smiley and frowny faces. If we were to have just our cosine function in red, what would be our range? 2 to negative 2. So our range on this one is everything else. Negative infinity to negative 2, inclusive 2 to infinity. To the right of our y-axis, what is the first vertical asymptote that we have? Pi over 2. So we're going to write x such that x does not equal pi over 2 plus or minus k pi. And then we're going to go down to the vertical asymptotes, and we're going to say that x equals pi over 2 plus or minus k pi. Yes. Squiggly thing, like this thing. There should be one at the end too. I just always forget to draw it. It's just like the bracket. So it's like a type of set or interval notation. It's just like the set of x's. So your domain would be everything if you didn't have all those vertical asymptotes. Oh, is everyone done here? Almost. Okay, now we good? Mm-hmm. All right. What are we going to compare secant to? Cos. Do we have an amplitude? No, so we're just going to move up and down 1. We're going to skip our domain. We're going to skip our range. Our period, we have to change because we have a b value. So 2 pi over b is our period, which is equal to pi. Our vertical asymptotes we're going to come back to, and then in order to find our phase shift or our horizontal shift, we set everything in this parentheses equal to 0. And at the end of the day, you get x equals negative pi halves. So we are going left pi halves. Our vertical shift is our k value, so what do we have? We're going up 1. So then we don't have to write it in anymore, but we're going to draw our midline so that we can reorient ourselves to this new graph that we have. While you're over there, you can draw your thick tick marks. And then does cosine start at the top of the wave or the middle of the wave? Top. So I'm going to draw for a second. So the parent function would start here. We moved our midline up. So that would be it. But then we also have to move to the left pi halves. So our new location for 0 is this dot right here. 2 negative pi halves. And our period changed. So when our period is pi, we have to use every tick mark in order to make sure that we get through everything in a pi rotation rather than a 2 pi rotation. So we're going to use every single tick mark. So it's going to be kind of tight. Okay. And then what do we do to our midline points? Our midline points, what do we do to our midline points? It is the asymptote. So you're going to draw your dotted lines anytime that you have something on the midline. And lastly, for our graph, we get to draw our peaks and our valleys. So remember, for the test, you really only have to do 2 full rotations, so you would need to show 2 ups and 2 downs, and you would be good. But it's good practice to show everything. On our just dotted lines, what's our range? What are we bouncing between? 0 and 2. So our range on this function is going to be everything that doesn't include that. What is our first dotted line to the right of our y-axis? Seven pi sixths, 3 pi fourths. What are these tick marks all worth? Pi over 4. So the big tick marks are pi halves. So our domain is all the x's such that the x does not equal pi fourths plus or minus k pi. And then you go down to your vertical asymptotes and you write the same thing, but you write that it's equal to. And that's all there is to inverse functions. So that's why we spent 3 days on cosine and sine, because we basically are spending a 4th day doing it again, but now we're just graphing a little bit differently.